Okay, so we talked about matrices, which are two-dimensional, and like I said, we'll be doing a lot of operations and calculations on them, but there are limitations to matrices, right? So one main drawback is its constraints. The constraints are that they all have to be the same values, okay? So basically a matrix has to have only numbers or only characters or only logical. You can't have a mixture of numbers and values, numerical values at the same time. For example, you can't have a patient's blood pressure in one column and blood type in the other, because one is numeric, one is character. So what we have, R has another data structure called data frames, which is probably the most popular format in R. So a data frame is similar to a matrix, that it's composed of vectors, right? But again, it has the same length, so this is the same restriction that matrix has, but it can be of different modes. So you can have a different column of different types. So you could have a column of characters, column of numerical values, and a column of logical values. So this is great because you could actually have different types of values in the same for the same individual or observation. So this is what makes it ideal for biomedical data or any type of data that you're working with. And often it's going to be the format of the data that when you load it into our workspace, that's the format it comes in. We can set the column names or the header of the data frame by using the names function or the column names. And you can actually access a specific column using a $sign. Okay, or you can use it the same way as a traditional matrix by giving it the square bracket and then giving it the column name like this inside the quote. Right. So this is the first column and this is whatever the name of the column is. You can also put names on the rows, and this becomes helpful because in our data frame that we're going to be working with, we're going to have we'll have tens, maybe hundreds of experiments, but we'll have about 30,000 or even 50,000 rows, right, of genes. So these are all our different genes. So if you wanted to get a specific value for a specific gene in your data frame, looking it up would be pretty difficult. So what we will do is we will assign the names of the rows for the names of the genes. So this way you can use the name of the gene to refer to which row you want, okay? And we'll set this by using row names in our data frame. And of course, our experiment names also can be used or set by using column names. Now lists are a little bit one more level of flexibility in data frames because it's basically a collection of objects. Okay, so it could be vectors, matrices, data frames, and they don't even have to be of the same length. So the way I like to think of this is some sort of a banner that, and basically a series of things, and in every element here could be a whole different size, different types of objects, or even an entire matrix. And basically you're accessing them using a couple of ways. One is using these double square brackets, or if they have names, you can use the names to refer to which element it's talking about. But what's nice about it is that you can store different types of information without taking up unnecessary space. And it's a good way to kind of couple things that you know belong together.